All right, students, we're going to graph cosecant today. And cosecant and secant are both related. Let's just refresh your memory. Cosecant of theta is defined as 1 over sine, and secant is 1 over cosine. Okay. Now, as far as why that is, that's just the definition. So we're going to focus on cosecant because it's related to sine. But our method for this is totally the same for this. Everything I say for this one, just apply it to cosine, and the rules are exactly the same. So we'll focus on cosecant. So the whole thing here, this is called a reciprocal identity. It is the reciprocal of sine. As such, it has an asymptote when sine of theta equals 0. Okay? Not when theta equals 0, but when sine is 0. Okay? Just a little quick side note here. It's just like when we did in first semester 2x minus 1. 1 over 2x minus 1. Okay, if we graph that, it doesn't have an asymptote at 0. It has an asymptote when the whole denominator equals 0. So the value that makes the whole denominator 0. Why? Because then you would have 1 divided by 0, and that is undefined. Which means the graph literally does not exist. There cannot be a point at that location. So, what we got to find out is when are those locations. Okay, so if it's 1 over sine, here's what we're going to do. We're going to sketch our graph of sine first. And again, this is why we spent so much time graphing sine. If you're not good with sine, go back and watch that video now, please. Okay, if you are good with sine, here's what it does. Sine goes up and down and finishes from 0 to 2 pi. All right? In between would be pi. Now, since, let's put it right over here. Secant is 1 over, sorry, scratch that. We're doing cosecant here. Cosecant is 1 over sine. All right. Then all these places where sine is 0, those are our problem locations. Well, I shouldn't say problem locations. Those are our asymptotes. Okay? Because at 0, you'd be trying to divide by 0. Can't do it. Asymptote. Plug in pi. Sine of pi would be 0. Can't do it. Asymptote. 2 pi. Sine of 2 pi is 0. Can't divide by it. Asymptote. So those are the asymptotes. Okay. That's not the actual graph yet. The graph itself looks like this. All right, let me see if I can get a different color here. And what's happening here is the y-axis would be right here, right where that asymptote is. Right here is at 1. And what happens is, because this is a reciprocal, when this one's going down, cosecant will be going up. This one also going up. And then on these points, 1 over 1 is still 1. So they actually touch at those points. But when the other one's going down, when sine goes down, this one goes up. So when sine is decreasing, secant is increasing, and vice versa. All right. And so those are your other locations. So if we erase the pencil mark of sine and just left the purple graphs, that's what cosecant is. That's what cosecant is. Now, if we go further, and we can do that, you would have another cup like that, and another asymptote. Now, a couple quick things. You might think, oh, these are just the same as parabolas. They're not. Parabolas don't have asymptotes. The fact that this has an asymptote means that if you went down, not a lot of interesting stuff's going to happen. It's just going to go pretty much straight. Not straight, but real close to the asymptote. And then the further you go, it'll just look like that. So the main information we want to know is where's the asymptote and what's this shape right around in here. All right. In the next video, I'll show you how to graph stuff like secant of 2x minus pi. What do you do when there's stuff inside? I'll show you that next. Thanks for watching.